Hello, everybody, and welcome to Chapter 4. We have made it through 3 chapters already. The time is flying by. This time we are on Section 1, and today we're talking about how we can graph things specifically in this form that we're going to call slope-intercept. So we've worked with that in the past, so we'll see some examples using this term slope-intercept. Okay? So we've talked a lot about slope, we've talked a lot about rate of change. Those are synonyms for the same thing. Now we'll focus on writing, graphing those linear equations. We can do things in slope-intercept form. We've talked about some other forms as well, but for this section we're going to focus on that slope-intercept only. We'll look at some real-world data, some problems with some context, to give us some real applications for these things. So as we look at some vocabulary, we'll see slope-intercept, and that is given by the equation here. This y equals mx plus b, we know, is not going away. So this is something that if we don't know yet, we must now learn. So if you're keeping up with the notes, this is something very easy to have down as a grade for your notebook. So please be on task with that as we jump into this chapter. We know m is our slope, given by the green here. That's always the number attached to x. And our y-intercept is given by the letter b, and that's always being added at the end. So in this example, the purple here, that is our y-intercept. That's where it crosses the y-axis on our graph. And our slope is the incline of the line. Like we see here, slope of 2, since that's the number attached to x. So we'll look at those two things. M and B are the factors we need to know as we work through these problems. So here is our first one. So we're given this sentence, so let's understand what's happening. It tells us to write an equation in that specific form that we're focusing on, slope-intercept form, which means y equals mx plus b. Okay? Now we're given a line with a slope of 1/4. Let's rewrite that in the correct position. And a y-intercept of -1. So slope is my m, y-intercept, this is my b. Now it tells me graph the equation. So we have m and b, we just found those. They're given. We can plug those in and that'll give us our equation. So here's our blank one. We always start with our blank equation. That's slope-intercept, all these letters here. Now we plug in what we know. So we're given m here, change m to 1/4. Boom. We're given b here, change b to a -1. We see that here. Now that's the equation. Y equals 1/4 x, take away 1. So we wanted to graph the equation because if you look back, they ask us in the last step to then graph it. So we can take that equation, and then we'll plot our y-intercept first, which we know is given by b, the number at the end. So this is our b value, and we know b is our y-intercept. So what does this tell me to do? Use the point 0, -1. In other words, on my y-axis going up and down, go down to -1, plot my point. So that's how we get that there. Now from there, we need to use the slope. We know our slope is 1/4, and our slope is always rise over the run. That is a vertical over the horizontal change. So from here, we're going to rise 1, given here, and we'll run, go over 4. So rise 1 over 4, 1, 2, 3, 4. Following that slope should get us here. Now, once you get those 2 points, you connect them with a line, and that allows us to then plot that line and have that finished product. Slope is 1/4, we use that. Y-intercept is -1, we use that. Draw your line to connect, and you are good to go on that example. So plotting, 2 steps. Slope, y-intercept, plot them both, and you will get that line drawn perfectly. So please have this picture down for this first example. Again, notes are very important to your grade, so let's keep up with that. Now, 1b. Same logic as what we just saw. We want to use those steps to write our equation again. So our slope is 4. Slope, we know, is the letter M. Our y-intercept is 3. That is the letter B. Now we'll take that and start with our blank equation. So we know for slope-intercept form, our blank equation is y equals mx plus b. So blank equation is always where we start. Now we know we just found m, they were given, and we just found b, that was also given. So what we will now do is rewrite our equation, but this time with m and b replaced for what they're equal to. So y should equal, m is 4, x plus b is a 3. And that is it. That is our equation. Plug in and rewrite and substitute. There you go. That is your equation in the proper form, slope-intercept. So for 1b of these options, we know that's wrong, wrong, wrong again. B is what we want. So 1b, y equals 4x plus 3 given a slope of 4 and a y-intercept of 3. Please have these numbers as information down and our equation and our answer. Now, we solved that, so let's double check, and there we see it. So if we look now, jump to our second type of example. We're asked to graph, and we're given our equation with our y and our x. So what do we do given all this information? How do we start? Well, we know we want to try to have everything in that form that we talked about. That's very important for lines. Y equals mx plus b. So we want to get y by itself because we see that in our form, y equals mx plus b, what's on the left side of the equal sign? Only y, right? So we want y alone. So we need to try to solve for that. So given the original, we need to get y by itself. So the first thing we can do is subtract away this 5x. So subtract that away from both sides. We'll get a new expression. On the left, we get just 4y. On the right, we get 8 minus 5x. Now, there's one more thing attached to the y. That is the 4, and these two things are tied by multiplication. So we know in order to get rid of that 4, we have to do the opposite of multiplication, which tells us to divide. So we will divide everything by 4, and that will leave y by itself. So on the left, we will get just y, and on the right, we're going to get a whole expression when we simplify those things. So please have those steps as we look to a couple more simplifications to finish this one off. Okay, so on the left we get just y. On the right we get negative 5 over 4x. Negative 5 over 4x, we can't simplify that. Plus 8 over 4, and 8 over 4 as a number is just 2. So when you carry all that out, this is our final product for our equation. Now the second part of this asks us to graph it. So we'll use the same process we did before. There's two things that we know, and that is our slope and our y-intercept. So this is our y-intercept b, this is our slope m. Notice that it is negative, so we will use those two things to draw our graph. So let's go over to the graph. Our y-intercept is at positive 2. So go to the y-axis, up and down. We'll go up 2, 1, 2. Plot that point. That's how you start. Now from this point, in order to know where to go, I just do what the slope says to do. So this tells me I have a negative 5 over 4. Now I know that's rise over run. So the vertical change going up and down, vertical change, tells me to go down 5. So from here I'll go down 5. 1, 2, 3, 4, 5. And my denominator going left and right tells me I need to go, this is left or right. My denominator tells me I need to go over to the right 4. So I go down 5, 1, 2, 3, 4, 5, and over 4, 1, 2, 3, 4. And I should plot that second point right there. So tracking with that slope, we get to here. Draw that second dot. Now you have two dots, and you know what can you draw between any 2 points? A straight line. So connect those with a line, draw that straight throughout your graph, and that will give you your solution. We use the slope, use the intercept. That's why we say slope-intercept form. So we have that one down. Please have that image as we move on. Now, 2b. We're given some options, so of these ones, which one is correct? So I want to first remember that this is best said in the form y equals mx add b. Given that, I want to get y by itself. So I can subtract 3x from both sides. So that will give me 2y equals negative 3x add 6. Okay. Now, the last thing I need to do to get y alone, it's tied with multiplication to the 2. So to get rid of it, we divide everything by 2. Now, what happens next? If I change my color back to red, on the left, we will get just y. On the right, we get negative 3 over 2 x plus 6 divided by 2, but instead of writing that, I know this is actually a whole number. Half of 6 is 3. So this is my equation, y equals negative 3 half x plus 3. So what information is given in this equation that I can pull out of here? This 3 is my y-intercept, that's my b value. And this negative 3 halves is my slope, that's the incline of the line. So it should cross the y-axis at 3. So let's check to see which one of these do that. Well, C is a negative, so that's wrong. D is at 1, 2, 3, so that's maybe. B is at 1, 2, so that's wrong. And A is also at 1, 2, so that looks wrong as well. So this is the only one with the right y-intercept. Let's double check to see, does it have the right slope? Does it rise negative 3 and go over 2? So if I pick these 2 points to make it simple, pick points on the corner. If I start here and I do what the slope says, so I go down 3, 1, 2, 3, and over 2, 1, 2. That is that slope, so that checks out. D is our solution. We use the slope, y-intercept, those two things we check, and we graph it with that line. So that makes sense for 2b. So please have that image for this one. And our red circle confirms. Now, 3a tells us to simply graph the line y equals negative 7. Now, we've talked about these special cases where you have y equals a number. And then there's another special case where you have x equals some number. When there is an equation that's just y equaling a number, that is a horizontal line, meaning it's flat. You're going to have a flat line on your graph somewhere. If you have something that's x equals a number, it is vertical. So those two cases do come up a significant amount of time. So if you know this, that makes this very simple. You're going to have a horizontal line at negative 7 for y. So plot that y-intercept at negative 7. You know the slope is flat. So you just draw that flat line down here where you're at negative 7 for y. Flat horizontal line. So we've worked on that, so hopefully that's not too new of a concept. And as we work through these, those will begin to make sense to you. So on your coordinate plane, go down to negative 7, plot that point, make sure that line is flat, and you should have that good to go for 3a, given y equals a negative 7. Now, 3b tells us to graph this equation. So there's one step we need to do here, and that is to get this whole thing solved for y. So we don't want the 5, so we could divide it away. So divide both sides by 5, and you get y equals 10 over 5, which is y equals 2. Now if y equals 2, where do we go on our graph? Well, we know y equals 2 is a horizontal line. It should be flat. So we'll go up to 2 on our plane and then have a flat line. So I know right away C is wrong because that's vertical. D is up here at y equals 5, so that's too high. B is down here at y equals 1, that's too low. A is just right, up at 1, 2, flat line. That is checking out for 3B. So y equals equations are simpler because you know there's no angle, it's just a flat line. So we should look forward to doing those because they are a lot faster. So we have A for this one. And have yourself a little image with the equation y equals 2. Now here's an example of a standardized test type question that's going to help us to practice our logic, our reasoning skills as we work through these kinds of examples, help you in the future for tests in our class, standardized tests in the future. So let's work through it. So we're asked the question and we're given a graph. It tells us which of the following is an equation in slope-intercept form for the line shown in the graph. So given this line, we want to know what is the slope and what is the y-intercept of this line. And then we find those two things, we plug it into our blank equation, and that'll give us the answer. So, first step is to read the test item. So you read the question and understand what you're being asked. That is a huge part of test taking skills. If you don't know what you're being asked, of course you can't answer the question properly. So we need to know what is the slope and what is the y-intercept. Slope and y-intercept. So first thing we see, our y-intercept is right here at a -3. So we see that here. So if we then go back to our graphs, our options, we know only something that has a -3 at the end here would make sense. So then we know A and C are both wrong. Now what else do we know? Well, if we track between 2 points, we can find the slope. So if we go between 2 points, we would see the slope is 2. And I can check that here. Say I pick this point and this point. How did I change? Well, I rose 2, went over 1. That's 2 over 1, which is just 2. So we know that that's the slope. So our equation then must be 2 for M minus 3 for B. So that gives us y equals 2x take away 3. That is our final equation for this standardized test example. So then we go back to our answer choices and we would see of the options we were given, the answer is B. And please have more than just saying B. You need to have this equation, 2x minus 3, given the graph. So hopefully that makes sense as we find our slopes, our intercepts, we work through those, sub in, use those tools to solve these problems. Now for B, same type of concept. Given a graph, we want to know which one of these equations is correct. It's always, for this section, in slope-intercept form. So we see that terminology comes up, so we know what we're talking about. Now, where's my intercept? So where does this line in blue cross the y-axis going up and down? It looks like it crosses right here at 1. So I know my b value is a positive 1, and that is the number added at the end of my equation. So if I look over here, this one has a plus 3. This one has a minus 1. D has a minus 1. So C is the only one with a positive 1, which is what we're looking for. So let's double check to see, is the slope a -3 for this? So if I pick 2 points and track the change between them. From here I would go down 1, 2, 3. That's a -3. And I would go over a positive 1. So that's 1. So my slope is -3 over 1, which is, in fact, a -3. So both of those are right. Our slope is M. Y-intercept B. Those were both correct. That checks out. So we know this choice is easy made for us. That is C. So please have that image of the line and the equation y equals -3x plus 1. Two things you have to find on these problems. Find your slope, find your y-intercept. Those are the things you need. Slope, y-intercept. All right, another real-world example with a little bit of context to talk about. So you don't need to have all the words for this, but you do need to make sure you have down the numbers. We will need the numbers to solve the problem. Okay. So the ideal maximum heart rate for a 25-year-old who exercises to burn fat is 117 beats per minute. So we're tracking the number of heartbeats per minute someone has, right? And typically your heart beats a few times a second. So you're going to have several beats per minute. So we see for every 5 years older than 25 that you are, the ideal rate drops 3 beats per minute, okay? Because your heart should be a little bit slower as you get older. Your body isn't working as hard. You're not as active, so it should be a little bit less. So we see that as we get older, that we expect the rate of these beats to go down. They ask us to write an equation to find the ideal maximum heart rate for anyone over 25 who is exercising to build fat, to burn fat. So in other words, we want to write an equation that allows us to compare the ages and the heart beats expected based on how old they are. So if we take what was given in this sentence and we pull out the numbers and the context that they're in, that's actually going to give us everything we need to know. So we know we want to find the ideal rate. We can call that any variable we want. For this one, we choose R. The ideal rate for how fast your heart should be beating is equal to how it's changing over time. We call that the rate of change. That's also your slope. Times how much older than 25 you are, because that's our comparison, right? Every time you get a year older than 25, you should be beating a little bit slower. Plus, what is the ideal rate for a 25-year-old? 117. So this is our starting point. And then every 5 years, you lose 3 beats per minute. So a -3 is going down in beats per minute. And then we divide by 5 because it takes 5 years for this 3 to come into effect. So we're multiplying times A, the number of years older than 25. So as an example, if A was 5, 5 times this -3/5 would mean we'd get a -3. And that makes sense because our ideal rate should be 3 less than what it was when you were 25. So this expression will allow us to then compare and understand what your ideal rate should be at any given time based on how old you are over 25. So our answer then, if we write that in a nice neat formula, your ideal rate is equal to -3/5 A plus 117. So just have this equation down as we close out this first part of this problem. Now, we want to graph that equation. So we see it has a slope of a -3/5 and a y-intercept of 117. So we'll plot those two things. So now you want to take your graph. You could go on the y-axis. You want it to be at 117. Years can't be less than 0 because we're talking about the real world. And every year it should go down with a slope of -3/5. So you should have a downward sloping line as you get years above 25. So please have a downward sloping line that crosses at 117 for 5B. Now as we look at 5C, they're asked us to find the ideal maximum rate for a person that's 55 years old, exercising to burn fat. So if someone's 55, how many years older than 25 are they? In other words, what is 55 take away 25? Well, that's 30. So they're 30 years older than 25. That's the number we plug into our formula. So from then on, it's just simplifying. So plug in a 30 here into what we already had. Simplify. We find the ideal rate for somebody 55 years old is now only at 99. So it's a little bit under 100 beats per minute. So as you get older, the ideal heart rate you should have should be a little bit less. So we can understand these linear equations. We find our slopes, our y-intercepts to solve these problems. Slope, y-intercept, m, b. So with one final example, and do not write the words on this, but please do have the numbers down. You have 150,000 as the average. We'll call that 0.15 million per year. Every year after 1986, consumers originally spent 3 million. We want to write an equation for the amount spent. So D is our amount spent. It will be equal to, we spend 0.15 million per year. Anytime you see per, it's going to be multiplying. So 0.15 times in the number of years. Every year they spend this much. Plus, how much did they originally spend in 86? 3 million. So 3 million originally, plus we spend this much more every year. So our equation should look like this. That's our slope here, and our y-intercept here. And which of these options is that? Looks like it has to be B. So have this down for our final example, 5D. Linear equations, slope, intercept, M, B. Two things, plug them in, substitute. That is it for this section as we jump into some practice.